I don't always listen to podcasts, but when I do, I listen to STEM Talk, interviewing the most interesting people in the world of science and technology. Stay curious, my friends.
Welcome to STEM Talk.
STEM Talk.
STEM Talk. STEM Talk.
Welcome to STEM Talk, where we introduce you to fascinating people who passionately inhabit the scientific and technical frontiers of our society.
There is orange soil. Well, don't move it till I see it. It's all over.
So I'm very excited about our interview today with Senator Jack Schmitt. Our co-host for today's interview is actually Tom Jones, who is a former NASA astronaut and also a colleague and senior research scientist here at IHMC. So I'm sitting here right now with Dr. Ken Ford. Ken, welcome.
Thank you, Don. Good to be here.
So Ken, I understand that you and Tom Jones served together on the NASA Advisory Council, which was led by Jack Schmitt.
Absolutely. Jack was the chairman and really a tremendously effective chairman. And I was honored to succeed him as chair of that august group. He made the transition as smooth as possible. Nobody could have been a better mentor when I took over the reins. So I appreciate that very much from Jack.
Absolutely. And as you said, that's actually a unique ability to be able to allow for a smooth transition from one director to another.
Yeah, he's tremendously good at that. And this is a special interview. Jack is one of the most impressive people I think I've ever met. A scientist, Apollo astronaut, United States senator, research scientist. The list goes on. And as everyone will hear, he's a broad, deep, and interesting fellow.
And he was also the last man on the moon, and he was the only geologist that was on the moon.
So absolutely, Don. It was December 1972 when Jack Schmitt and Gene Cernan landed on the moon. We were all glued to our TVs. I was in 11th grade. And, Jack is the only scientist to ever walk on the moon. And he and Gene were the last 12 humans to ever visit the moon. So if one thinks about it, only 12 folks have ever been there. And Jack's one of them, and really the last one. And in 1976, he was elected to the United States Senate and is the only natural scientist to serve in the Senate since Thomas Jefferson. And I think the Senate has not been better for that.
Both Jack and Gene Cernan had a lot of fun while they were on the moon, including reenacting an Olympic-style hammer throw while they were on the moon.
Absolutely. Those folks had fun, and you could sense their palpable sense of wonder and excitement. And it still shines through on scratchy old recordings on YouTube of their time on the surface. Jack, a scientist until the end, always conducting experiments. One of the very last things Jack did on the lunar surface was to throw his geologist's hammer as far as possible. This worked pretty well, given the moon's 1/6 gravity. We will now turn back the hands of time and listen to Jack pleading for permission to make the mighty throw, and being warned by Gene Cernan to be careful not to hit the lunar module, which, had they done so, would have probably warranted a Darwin Award.
Go ahead. Oh, there. Poor little hammer. Let me throw the hammer. Okay? Let me throw the hammer. Please. It's all yours. You got the You deserve it. A hammer thrower, you're a geologist, you ought to be able to throw it. You ready? Go ahead. You ready for this? Ready for this? Yeah. Don't hit the lamp or the outstep. Look at that. Look at that. Look at that. Beautiful. Looked like it was going 1,000,000 miles, but it really didn't. For the outstep.
Wow, you can really hear the boyish enthusiasm in Jack's voice in that clip.
Absolutely. I think that enthusiasm and the passion that drives it has really characterized his remarkable life.
And it's contagious for the rest of us, so it's really interesting to hear.
I was going to say, if Jack had asked permission to skip very fast down a hill on the moon, it would have been denied. But he was on the moon, and what are they going to do about it? And so down he goes, singing away.
And he made that happen. And I can think of no better way to kick off this interview than to listen to Jack Schmitt and Gene Cernan singing on the moon while skipping and hopping down the hill.
I was strolling on the moon one day in a merry, merry month of December. Now, May, when much to my surprise, a pair of bunny eyes. Do-do-do-do-do. Oh, is this a neat way to travel? Isn't it great? Dum-da-dum-dum-dum. 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 I like to skip along, but me, boy.
It really it was a delightful experience to be there. We had a lot of fun. I did anyway, and that I think the singing part of that just illustrates how enjoyable the whole mission was, in spite of some of the difficulties we had with fatigue in our arms and other things.
Oh, hey! Wait a minute. What? Where are the reflections? I've been fooled once. There is orange soil. Well, don't move it till I see it. It's all over. Orange! Don't move it till I see it. I've stirred it up with my feet. Hey, it is! I can see it from here. It's orange. Wait a minute, let me put my visor up. It's still orange. Sure it is. Crazy. Orange. I've got to dig a trench, Houston. Copy that. I guess we better work fast. His wits. It really is. Is this the same color as these? Temperature on the SEP is about 100 and, temperature on the SEP is about 102. It's almost the same color as the LMP decal on my camera. Okay, copy that. That is orange, Jack.
So, Dr. Schmitt, you sounded pretty excited when you discovered orange soil on the moon. What was that soil, and why was it so significant?
The soil itself turned out to be volcanic ash. It's what we call pyroclastic ash. It was produced in a volatile eruption, a volcanic eruption. And we know from approximately how long ago that happened, about 3.5 billion years ago. That's billion with a B. But it was one of the last things that happened volcanically in the Valley of Taurus Littoral. And in fact, it turned out the orange soil was just the topmost layer of a number of layers of volcanic ash, the rest of which were largely black in color. They had devitrified enough so that the color of the glass had turned to be clear rather than orange. Turns out that discovery is one of the more important that we had in the Apollo program from a scientific point of view, because the ash contains not only the volatiles that erupted, but inside the individual glass spheres, which are very, very small, they're less than 40 microns in average diameter. Inside those spheres, there are small olivine crystals, inside of which, in turn, they have now discovered water, indigenous lunar water. So this soil has given us another source of water that's being sensed by other systems at the poles of the moon, but it also has really thrown some disarray into the hypothesis that the moon formed by a giant impact of a Mars-sized asteroid on the Earth. The temperatures that are reached in an impact of that kind would be so high that you would not expect to see any water remaining in the moon or any of the other volatiles that you see in these pyroclastic deposits. So that has tended to make it more difficult to adhere to that hypothesis, although most of my colleagues still maintain it. I have not been one to advocate that for a long, long time.
I can absolutely see why you were excited then with that finding. You traveled a long road to the moon, so what motivated you to get into science and geology in the first place?
I was exposed to geology and to an interest in science by both my parents. And I think that's the fundamental thing. My father was a geologist, an economic geologist, primarily concerned with ore deposits here on Earth. My mother was not a scientist by education, but she was extremely interested in botany and ornithology and the like. And so, I had that kind of exposure from the time I can remember. And I think that's what led me in that direction.
So, Jack, when you were in the Apollo program, I was just a student following the exploits of you and all your colleagues as you headed for the moon. And the story about how you became an astronaut is really intriguing to me. You weren't out of the typical test pilot model of astronauts back in the 60s. Can you tell us about how you made your way to the Apollo program and how you were selected as an astronaut?
Tom, it goes back to some NASA managers in the early 1960s and some scientists like Eugene Shoemaker and Harry Hess, Hess of Princeton, Shoemaker of the U.S. Geological Survey, spending a great deal of their time advocating with NASA, with Homer Newell, who was the head of science at NASA headquarters, with people like George Lowe and Bob Gilruth, and spending time persuading them gradually that at some early point, scientists and engineers who might not be pilots should be brought into the program, and that culminated in a request for applications by NASA in late 1964 that appeared on a bulletin board at the astrogeology headquarters of the USGS in Flagstaff, Arizona. When I saw that on the bulletin board, I hesitated about 10 seconds and figuratively raised my hand and said, yeah, let's do that. And I think the main motivation that I had, having already developed an interest in space and space science by working with Shoemaker and Flagstaff, and actually having been in Norway with an international student community when Sputnik first flew, all of these things conspired to make me feel that if I had a chance to potentially go to the moon and operate as a field geologist on the moon, and I didn't take it, I would regret it. So I raised my hand, as I said, and gradually worked my way through the selection process.
So, Dr. Schmitt, you played a key role in helping train other Apollo astronauts for their geological tasks on their lunar expeditions. So why were you chosen as the first and only scientist to go to the moon?
I think the primary reason would have to be that by the time it was clear that Apollo 17 was going to be the last mission, that NASA headquarters increased the pressure on Deke Slayton, and that's pretty clear in his book, Deke, to put me on the last crew, feeling that Apollo ought to have at least one scientist among the moonwalkers. I certainly agreed with that, but it was, I'm sure, not an easy decision for anybody for me to replace Joe Engle on the Apollo 17 crew. That came, though, I think, because in part because I had been able to become a good jet pilot, flying T-38s, a good helicopter pilot, flying H-13s, and also had worked very hard on all the lunar missions in various capacities as support crew member, primarily for the science, but also for the stowage of the lunar module related to the science and other aspects of it. And then also helping the Apollo 8 crew plan their lunar orbit mission. Spent a lot of time with Frank Borman and Bill Anders and Jim Lovell on that. And then continued to just be very, very active in offering support to all the missions and being capable of, as anybody, I think, to fly the lunar module when the time came to actually select a crew. So a lot of things came together, but I have to give a lot of other people, in fact, most of the credit for me actually ending up on Apollo 17.
I don't always listen to podcasts, but when I do, I listen to STEM Talk, interviewing the most interesting people in the world of science and technology. Stay curious, my friends.
So let's take you back to the beginning of the mission, and you've been training for Apollo 17. Now you're strapped into a Saturn V, getting ready to head for the moon on your very first flight. Can you put us all in the mind of what you were going through in your head as you were contemplating that last few minutes of the countdown?
Well, I was building up in my mind a baseline of what the various gauges were reading, so that I would, as I did in simulation after simulation, and as you well recall, you're looking for changes in that baseline of what various pressures and quantities and other things were in the cabin. It was part of the training in the simulations, just a natural thing, to become competitive with the flight controllers back in Houston and in the launch control room, to see if you could see the problems that the simulation supervisor, SimSoup, would put into the system before the ground saw them. So it was just a natural thing for me to do, based on the simulation training that we had. And I was doing that up until the 32nd point in the countdown, when our countdown was terminated, temporarily it turns out, but terminated by the launch control computer. The computer had seen something that it didn't like, and as it was told to do, it said, we're going to stop this until we figure out what's wrong. And what it had seen was that a signal had not been sent to pressurize one of the tanks in the Saturn V, the S2 stage. I think it was the oxygen tank. It turns out that tank was fully pressurized. We could have launched without any problem, because one of the launch controllers had seen that the tank had not pressurized, and he just pressed a button and pressurized it. So we were fine. It's just the computer didn't know we were fine, and then it took 2 hours and 40 minutes for that all to work its way through. Within 5 minutes, Skip Chauvin, who was one of the launch controllers, came on the line and told us what the problem was. But the rest of the time was spent trying to convince management that not only they knew what the problem was, but that the fix was going to solve that problem. The fix actually turned out to be to hardwire in that vintage computers. You actually put a shunt around that particular point, those 2 points in the computer, so it told the computer just to ignore that particular sensor. So we had to go through 2 countdowns. Eventually, after 2 hours and 32 minutes, they restarted the countdown at 8 minutes, and so we got to do it all over again. Now, one of the things that comes out of that, though, is that as soon as the first stage, the S1, ignited, you immediately are subjected to extremely heavy, low-frequency vibration. And all of that preparation that I had done to try to monitor the gauges and the pressures and the flow rates and things like that went out the window, so to speak, because I couldn't read the gauges. The panel in front of me was vibrating, so I couldn't read it. And so the launch, all my preparations during launch over in the right-hand seat to be a good flight engineer for the command module just didn't pay off. But I'll always remember seeing those gauges vibrating in front of my eyes, so they were unreadable.
Well, that gave you some time there sitting in the cockpit during that hold then to think about whether the mission was actually going to come off and whether you were going to come back with the rest of the crew. Those thoughts of mortality ever go through an Apollo astronaut's mind?
Well, they didn't go through mine. The thing that goes through is, number one is you don't want to recycle. That means another month of training. And once I heard Skip talk about what the problem was, I was absolutely convinced that they knew the problem. I'd worked with him in various chamber tests and things like that. And so I was very confident that they'd figure it out and they'd come up with a fix and that we would almost certainly launch. I'm not sure the rest of the crew was that confident, but I was. And so I just dozed off. I caught a few Z's, which is the thing. You put me on my back with some humming and vibration, and I'll go to sleep very easily.
That's, I think, tells us more about your state of mind than anything else. That's good.
Well, you're always looking for a chance to get some sleep, because we knew that sleep is sometimes hard to come by in space, particularly if you later on might have a problem. We never had any such problems, but still, it's very important to grab those Z's when you can.
I agree. So jumping forward a few days, and you and Gene Cernan land on the moon, and you have run through all of the steps of flying the lunar module down to a safe touchdown. At some point, you had a chance to finally look out the window and look at the scene before you. What were your first impressions of being on the moon finally?
Well, the very first impression was at pitchover during the landing sequence, and that's the first time either one of us had a chance to really see where we were headed. But my job was basically to keep my head in the cockpit. But I took a quick glance out, and at the time of pitchover, which occurred at 8,000 feet above the surface, we weren't that far above the tops of the mountains on either side of the valley. So it was quite spectacular just to glance out there for a few seconds and see these mountains going by out the right-hand window of the Challenger. Once we landed and had a chance to look around, well, then it mainly, the thought I had mainly was waiting for the ground to say you get to stay. Of course, we were looking and took a few pictures as fast as we could, but the ground was looking at all the various systems in the Challenger and making a judgment that there were nothing that would in any way keep us from staying and actually having the excursions that we later had.
So you finally get the confirmation that you're good for an extended stay, and you've got this chance to look out the window of the LEM before your first spacewalk, before your first moonwalk, as a geologist, and take in the scene. Did it surprise you compared to the pre-flight preparation?
It did not surprise me overall because of what other crews had said and the photographs that we had from their missions, and my knowledge of the lunar samples that had come back on those missions. But one of the things that surprised me was just how high the mountains looked on either side of us compared to what I thought they would. I knew they were high. We're talking about 1,600 to 2,100 meters above the surface. That's deeper than the Grand Canyon for the most part. And but also, I think the thing that I remember being surprised at most is that when you looked over to the North Massif, the north side of the valley, you could actually see the tracks that boulders had left when they rolled down that mountain. And we had not really seen that in any of the pictures. The pictures did not have sufficient resolution to see those tracks. And that immediately told this geologist that, hey, we're going to be able to sample boulders that come from up and know where they came from up on the mountain. And for geologists, that having that sequence is very, very important.
Now, Jack, your commander on Apollo 17 was Gene Cernan, the last man to walk on the moon. And he wrote a book called Last Man on the Moon, and in which he called you Dr. Rock. He said you were the preeminent moon geologist of the day. Would you agree with that assessment? And did you know Gene well before you were assigned to the Apollo 17 mission?
Well, I did not know Gene well. We had not overlapped on any of the missions. I was in the middle of training for Apollo 15 when he was backup crew commander for Apollo 14. And although the training program was one that I had initiated with Al Shepard's approval, of course, that they went through, I did not have any direct contact with them because of my training schedule. I'd already been assigned as a backup crewman on Apollo 15, which would have put me in line for Apollo 18, by the way, but soon after that, Apollo 18 was canceled. The term Dr. Rock, actually, Gene took that from what the flight controllers call me. I spent so much time in mission control during the missions and simulations that for all the missions, all the Apollo missions, that the flight controllers at that time started to refer to me as Dr. Rock, and that's where that term came from. Out of that association with these remarkable young men that made up the mission control team.
And Cernan, in fact, said that you turned out to be a top-notch astronaut and lunar module pilot, and you talked about some of your flying experience that got you up to that level of expertise. So he also said that when you would curl up for fun, when you were just looking to have some fun, you would curl up with an operations manual. Was it that dry a personality that you were exhibiting back then?
Well, I spent an awful lot of time making sure that I was, if not the best lunar module pilot, certainly number two. I would say Fred Hayes probably knew more about the lunar module than anyone alive at the time, and even today. But I felt like I needed to be as expert as anybody in the operation of the lunar module, the systems, the operations overall, and the like. And so I did spend an awful lot of time not only with the manuals, but more importantly, with the people who knew the manuals, had written them, knew a lot more about all the systems than I could ever learn, but trying to get as expert as I could, and also participated in the simulations vigorously, so that learning experience continued into actual operations.
And did that require you to be up at Bethpage on Long Island a lot, to be at the LEM factory, or did you get most of your hands-on time in the simulator and down at the Cape, perhaps?
Most of my hands-on time was as a backup crewman in support of Jim Irwin for Apollo 15, and also, of course, as the prime crew on Apollo 17. I went 15 months with training for Apollo 15, and then immediately was assigned to Apollo 17. So that never stopped. There were about 30 months of continuous training, much of which, of course, was in simulators.
And Dr. Schmitt, there's that famous video of you falling on the moon.
Oh, dadgummit. Jack Schmitt having a few problems.
Was keeping your balance on the moon a real challenge? And more importantly, do you think you were the only person to say the word dadgummit on the moon?
I would have to go back and listen to all the audio to see if I was the only person to say dadgummit. But the thing about balance on the moon, yes, it's more awkward. 1/6 gravity doesn't give your body sensors quite as much information as 1 gravity does. Relative to your center of gravity, plus because of the backpack, the mass of the backpack, you have your center of gravity offset about 2 inches towards the rear, and that's why when you see astronauts just standing, they're leaning forward all the time. You're automatically putting that center of gravity over your feet. The falling is something that you didn't worry about. The suit was outstanding. It was like wearing a suit of armor. I don't think anybody had any great concern about puncturing the suit, at least not on the rocks of the lunar surface. And falling would be like being a child again, 1/6 your height. You just didn't fall very hard, again, because of 1/6 gravity. The suit was stiff, and so when you see me having trouble getting up, and hanging on to a bag or something like that, it's because of the constraints of the suit. For that period of time, the Apollo A7LB suit, which it was called, really was a remarkable technological development. And in particular, one enabling technology was there that allowed us to work for up to 7.5 to 8 hours in a pressurized condition, sometimes a little bit longer, and that was the water-cooled underwear. Without having that kind of cooling, if you had to depend on gas cooling, you would not have worked very long on the lunar surface. And so being able to control your body temperature with that water-cooled underwear was absolutely essential for the kind of exploration that the astronauts were able to do.
Okay, Senator Schmitt, you spent 3 moonwalks exploring our nearest neighbor in space. And so you were in intimate contact with the moon's surface. Now you've had 40 plus years to think about what you saw up there and what you learned up there. What were the most important results from Apollo 17 specifically? And then maybe you could put that in the larger picture of what were the most important science results coming from Apollo.
The science of the moon, based on the Apollo experience and sample collection, continues to this day. There's been a continuous level of activity for many decades with researchers in various laboratories around the United States and abroad that continues to benefit from the sample collection of the Apollo missions. It's the gift, the samples are the gift that keeps on giving. And one of the reasons for that is that technology continues to advance so that people can do new things with those samples that were impossible 43 years ago. And so we're the community of which I hope I'm still a part continues to work. In fact, one of the biggest assistants in interpreting Apollo data has come from the Lunar Reconnaissance Orbiter spacecraft that is still in orbit around the moon. The camera on that spacecraft, the radar system on that spacecraft have provided a whole new opportunity to look at the field geology context of the samples that we got. High resolution. Of course, when you're on the surface, you're confined to the time and the traverse that you have planned or undertake. And now we have this extremely detailed imagery from the Lunar Reconnaissance Orbiter, or LRO, as well as this new data from radar, which has disclosed all sorts of things. For example, we found new faults in the Valley of Taurus Littrow that we didn't know were there as a result of that radar information. So the bottom line is that we're continuing to work. In fact, I'm in the process of putting together a paper for that ties the new information that's come from LRO, from the mini RF radar, and also from the mineralogical mapper that flew on the Chandrayaan spacecraft flown by the country of India. So there's an awful lot of activity still. We're learning new things all the time just because we think with new information, and logic doesn't disappear. And people, I hope, are continuing to change their mind about some of the early interpretations. I certainly have. Now, with respect to Apollo in general, I would say that probably the most important results of Apollo from a geological point of view is that we have gained an understanding of the early history of the Earth. That history of the Earth has been obscure to us because of the dynamic processes that take place continuously on this planet. The moon has had its development arrested at about 3.7 billion years ago, and that is almost exactly the time in Earth history beyond which we cannot see anything, up until recently, anything very significant. And so the moon has told us that early history of the Earth was extraordinarily violent, that the Earth was exposed to horrendous impacts of objects coming from space, comets and asteroids, and that it was also the time in which the complex molecular evolution that led to life was taking place. So that has forced a whole new realm of thinking about how life began, about what this environment was in which life began, that we really probably would not have had without the moon to study first. Really extraordinary, important, at least with respect to that understanding of what we call the Hadean period here on Earth. Also, we have gained new insights into how the moon may have formed. I am not of the of the group, the majority group that believes the moon formed as a result of a giant impact of a Mars-sized object on a young Earth. I think rather the evidence is better explained by an independent accretion of the moon in near Earth orbit and then being captured by the Earth. But nevertheless, we have been forced, as a result of the Apollo sample collection and the remote sensing information that's been gathered and still is gathered today, into thinking new thoughts about how the moon may have formed over those that were available to us before Apollo. There are many other detailed aspects of lunar science that have come out of the Apollo sample collection, the observations of the astronauts, the photography that we obtained while on the moon. But I would say those two things: the origin of the moon, but most importantly, the early history of the Earth, have created the insights that we would not have had without the moon.
Mm-hmm. And back to your discovery of this orange soil on your moonwalks, how does that fit into the moon's history, and what are the implications of finding that fire fountain volcanic ash for the history of the moon, and whether the moon is still an active body?
Well, I'm glad you asked. The orange volcanic ash is probably the one sample that makes it very difficult for the moon to have been formed by a giant impact. And the reason I say that is that the volatile components associated with that ash not only imply but require that there be reservoirs of volatiles deep within the moon that could be incorporated in the volcanic, what we call pyroclastic eruption that created this very, very fine ash on the surface of the moon. And it's not isolated to Apollo 17 landing site of Taurus Littrow, but we see vast regional deposits on the moon of similar kinds of materials. The volatile that is of most interest, I think, to people is one that was just discovered or 3 or 4 years ago in inclusions in the olivine crystals that you find in this ash, and it's water. And so we have finally found that there was indigenous water inside the moon, as well as other volatile elements. And to have those reside in the moon after a giant impact is very, very difficult to explain, and has caused the community that likes the idea of the hypothesis of a giant impact to go back to the drawing board and try to figure out how do we explain in these computer models the existence of these reservoirs of volatile elements. And by volatile elements, I mean not just water, but chlorine, fluorine, lead, tellurium, zinc, all of these various elements that have relatively high volatility. The orange soil is probably, from the point of view of understanding the origin of the moon, is probably the most critical sample that we found in Apollo.
STEM Talk is an educational service of the Florida Institute for Human and Machine Cognition, a not-for-profit research lab pioneering groundbreaking technologies aimed at leveraging and extending human cognition, perception, locomotion, and resilience.
So Dr. Schmitt, it seems like we know a fair bit about the big picture story of the origin of the moon. So why do you think we should return to the moon?
Well, the primary reason for returning to the moon, or reasons, are probably twofold. One is there are tremendously valuable resources there, that many of which can be used to further our exploration of the solar system, to supply space stations in Earth orbit from a much more, once established, much more economical basis than we can from Earth. Those resources include a light isotope of helium called helium-3, which is the one resource that might be returned to Earth as a fuel for fusion power. It's an ideal fuel for fusion power. It allows you to have, in a sense, nuclear power without any radioactivity being produced in the reactors. It's and at very high efficiency. So the moon is our reservoir of that isotope of helium. And someday I am convinced, having written a book on the subject, I am convinced that humankind will benefit greatly from that resource. The other reason I think for returning to the moon, and in current context, probably the primary one, is it's the fastest way to get us to Mars. Mars is going to be extremely difficult for many, many reasons, as many people understand. We don't really yet understand how to either transit to Mars safely or to land safely on that planet. It's going to be very, very difficult. For example, there's just enough atmosphere on Mars to cause problems and not enough to do you much good in terms of entry, descent, and landing. And so the moon gives us a stepping stone in order to work these operational and technical details out. It's only 3 days away from Earth. It can be used for simulations. It provides resources that can be very helpful for trips to Mars. And so I just, my gut feeling, as well as I think good technical reasoning, says that the fastest way to get human beings to Mars is by way of the settlement of the moon, and then from that learning base, proceed on to Mars. It's going to take at least 2 generations, I think, of young men and women to get us to Mars. They're going to have to learn again how to work in deep space. It's a much higher risk environment to work in than near Earth orbit, and we're just going to have to recognize that it's going to take time, and it's going to take a couple generations of young people in order to make it happen. That's one of the things I think we forget about Apollo, is that it was a young person's program. The 10 years roughly of Apollo, you were really using people whose average age was in their 20s. And people of that age really have the courage, the stamina, the motivation, the imagination to move these kinds of very complex technical efforts forward. And we have to recognize that when we start to think about going to Mars. You're not going to do it with an older generation. You need a young generation. And another good example of how that has happened and continues to happen, it's one of the few places where, maybe the only place where it does, and that is in the nuclear Navy. The nuclear Navy is a young person's Navy. And we have to remember that at least the Navy figured out how to keep that organization young. And that's, if I were going to make one recommendation on what it takes to get to Mars, it's an agency that can stay young and stay young continuously.
So Dr. Schmitt, what might have been accomplished on the moon with a few more Apollo expeditions, which were canceled by the Nixon administration and Congress?
Yeah, a lot of scientific things could have been accomplished. We barely scratched the surface in terms of exploring the moon. And we know many, many things now as a result of the Lunar Reconnaissance Orbiter imagery and other information of very important scientific areas to go, not the least of which is the far side. And the South Pole Aitken Basin, the Great Big Basin Tsiolkovsky, which I tried to get Apollo 17 to go to, but that's another story. And so from a pure science point of view, a great deal more can be done and could have been done with the additional missions. We haven't been to the poles yet. We haven't been to Orientale, which is the big basin, the youngest big basin on the moon. A great deal of things to tell us about what kind of things may have been happening on Earth during that period of time. Yes, the other 3 missions might well have benefited the Earth sciences, the planetary sciences, very, very much. One thing you have to, though, I think, in understanding the history, is that the initial decision to limit the Apollo program was made in the Johnson administration. That was a budgetary decision to only buy 10 Saturn Vs. The Saturn V is the true enabling technology for working in deep space during Apollo, and could be again today with an upgraded Saturn V concept. But that initial decision was made in the Johnson administration. It was confirmed then by the Nixon administration, not reversed, and not reversed by the Congress either. So if you want to blame anyone for the decision to limit Apollo, it goes back to that time. But a lot of other things happened along the way that led to the cancellation of the last 3 Saturn V missions to the moon. But I think the primary ones were made in limiting the buy of the Saturn V, and which inevitably meant that at some point that production line was going to be terminated. Had, with 2020 hindsight, maybe 15 hindsight, keeping the production line of Saturn V's moving, keeping the upgrades coming for that concept of a system would have meant that we would have had a continuing capability to work in deep space with one major advantage, and that is the intercept of any asteroid that might be on a trajectory to impact the Earth, and to do something about it. For a brief period of time in the late 1960s, early 1970s, we did have the capability to do something about asteroid impact on the Earth. We do not have that capability today. It should be in the back of everybody's mind as one of the primary reasons to have a heavy lift launch capability comparable to the Saturn V as soon as we can in the future. And meanwhile, that capability can be used for deep space exploration, science, and as well as just the furtherance of what I think is an innate human desire to explore the unknown.
Okay, Jack, let's circle back to your enthusiasm for going back to the moon for the commercial and energy mining potential there. And when we get to talking about that, you sound almost as excited as if you were still on the moon back in 1972. So let's get into that topic. And Don, why don't you take the next question?
So, Dr. Schmitt, when you last spoke at IHMC, you were hoping to inspire an effort to mine the moon for helium-3, which we talked about a little bit earlier in this podcast. Why is it found more on the moon and not on Earth?
The fundamental reason is that the moon has no atmosphere of any sensible amount. There's a transient atmosphere, but it's very, very minor in terms of any protection that it may provide the moon. And therefore, the helium-3, helium, hydrogen, protons, and the like that are produced in the sun by the fusion processes going on there and are spewed out into space as part of the solar wind, when they impact the moon, they're captured. They embed themselves in the upper surfaces of the regolith of the moon, the debris layer that's there, and are preserved. So it is a resource that is continually replenished, not very rapidly, but since that regolith of the moon has been exposed to the solar wind for literally billions of years, the resource has reached a steady state where the amount lost is gained again from the solar wind. So that would be the primary reason. The lack of a lunar atmosphere allows the moon to continue to collect this helium-3 isotope. It's not abundant, but it is so valuable in terms of its energy content that the economics, I think, begin to make sense.
I don't always listen to podcasts, but when I do, I listen to STEM Talk, interviewing the most interesting people in the world of science and technology. Stay curious, my friends.
So, Dr. Schmitt, as we consider a possible return to the moon for either energy or scientific purposes, do you think that robots can pick up on the moon where you left off, or do you think that human explorers are still going to be essential on the lunar surface?
Well, on the one hand, I think human explorers, where they can operate, like on the moon, are obviously very capable of efficient exploration. On the other hand, I think there's very definitely a role for robotic explorers, particularly in pre-planning human exploration and helping to pre-plan human exploration and in follow-up to that exploration. I can think of all sorts of things that a robot could do in the Valley of Taurus Littoral to gather information that builds on what we gathered as human explorers. And I think the work that many people have done with the Mars explorers demonstrates very clearly what kind of capabilities one can build into robots today, and that those were going to be enhanced in the future. But still having the instantaneous reprogrammability of a trained and experienced human being exploring a planet is going to be, I think, extraordinarily valuable. Now, there's some planets that you will not be able to put human beings on in the foreseeable future. But where we can do that, we should take advantage of the capability that humans bring.
So it sounds like you think humans and robots are complementary to each other. And you've mentioned the lunar context there. Mars, we have the rovers there already. And let's think 20 years in the future. Do you think that robot technology will come along where you can have a human and a robot walking side by side and working together as explorers?
Well, that idea has been advocated by some very reputable people. I tend to be a little bit more skeptical about it because I would find, based on my limited thinking on the subject, that a robot field assistant might get in the way. They're much harder to direct than a human graduate student field assistants, and and since they haven't seemed to be taking their place yet in geological exploration here on Earth with humans, they certainly have been important in deep sea exploration. But as a field assistant, I'm not sure, I'm yet convinced that a robot will work. Now, having access to sophisticated, rapid analytical information in the field would be very, very nice. And my thought is that we should be looking more at some easily handled, multifaceted sensor system that allows a field geologist to gather information that will help in the field geological exploration. I just have a feeling that if you had a robot that you were trying to direct to follow you or to go over and look at a rock or something like that, that you'd probably just pick it up and take it there. And so I am of the opinion that I'd like to have some small, easily handled set of sensors that I could just take over to a rock, place on it, get the information, and then move on.
When you returned from Apollo 17, when did you think that humans would return to the moon?
Well, we knew it wouldn't be soon that humans would return to the moon because, again, as I indicated, the Saturn V's were not going to be available. But I have to admit that I did not think that it would be over 50 years. And it is going to be, I'm afraid, at least that. It has to be a generational gap in order to get things going again.
So looking down the road at future human exploration, do you think the moon is going to be the best candidate for establishing humans permanently in space, or do you think we should look further out to Mars, perhaps?
No, I think the moon is obviously the obvious candidate in my opinion. Because it's close, because the resources are there to support a settlement economically, and there are resources that are at least the helium-3 resource will be, I think, of significant value to the home planet. No, a settlement on the moon, I think, is quite doable, and should be the first step. It is not quite so clear that there's any economic benefit to having a settlement on Mars, but I said that once about the moon too, and we'll just have to wait and see what develops with what actual exploration of Mars actually shows us is important.
Well, Jack, in order to get people back to the moon or to Mars one day, it's going to take a national commitment of the sort we saw back in the 60s and 70s. And you had been a senator for 6 years in the 1980s. What's different about our view of space exploration today than our outlook on it back in the Apollo era?
I think there are two primary things, Tom, that I would suggest are different today than in the '60s. Maybe let's say three. The geopolitical context is not understood. I think the geopolitical context is no different than it was for Apollo, but it is the leadership of the country seems not to understand that context. That this is still a very dangerous world. That being the leader in space exploration is important in the geopolitical context now as it was then. Also, I think technology has advanced. Clearly, I don't think there's any problem in the technology base with moving very rapidly to return to the moon and then go on to Mars from that base. I think our education system may not have developed as much as it needs to in order to have that reservoir of young men and women who can make these kind of things happen successfully. But I would be most concerned about the risk-averse aspect of the national media and the lack of understanding, I think, in leadership of how critical space is in the geopolitical context of the world.
So do you think, given all these factors, that we as a nation were more able to get things done back then?
Well, we had a lot of things going for us in the pre-Apollo days, and we had the leadership that recognized the challenge. We had the young Sputnik generation who were ready to do something with that challenge. We had a technology base that was more than that. It turned out to be at least adequate to the job, if not more so. That geopolitical challenge of the Cold War was clearly understood by the leadership of the country. I don't see all of those conditions here today, particularly on the leadership side of things. But nevertheless, I think it could happen. And one thing that's different today is that the settlement of the moon could be a private sector initiative if investors became less risk averse about doing something like that. And of course, they would need the support of the federal government, but they don't necessarily need the funding of the federal government to make it happen. There are legal aspects to space activities that require the United States government to be supportive internationally as well as domestically. But nevertheless, I think that's different. The potential for a private initiative to go back to the moon is very real, where a private initiative to go to the moon in the 1960s really was not on the table.
STEM Talk is an educational service of the Florida Institute for Human and Machine Cognition, a not-for-profit research lab pioneering groundbreaking technologies aimed at leveraging and extending human cognition, perception, locomotion, and resilience.
Senator Schmitt, I mentioned earlier the book that you wrote on helium-3, which is a very interesting read. Do you have any books that you found influenced you as a promising scientist and explorer?
Well, as a young man and young boy, I read an awful lot of history, encouraged by my parents, of course, but I just enjoyed history, exploration history, as well as history in general. I think one series of books that a 3-volume series that Tom would be familiar with on leadership in the Civil War and the war between the states. That probably taught me a great deal about how to evaluate leaders and those being led. And that was
Bruce Catton?
No, that was the Study in Command. I'm trying to remember the main title, Tom. The 3-volume series written by the Lee biographer, based on his
Douglas Freeman, I think his name was, right?
Yeah, Freeman's book.
Lee's Lieutenants, perhaps.
Lee's Lieutenants, that's it. You got it. That was a very, very interesting read. I was reading it while I was training for Apollo 15, as a matter of fact, as my recreational reading. I'm just giving you examples of the kind of books that there's a book by Tuchman called Stilwell and the American Experience in China. Again, having to do with leadership and observation of the world around you. That was based on Stilwell's diaries. And it caused me to start asking NASA personnel if they were keeping diaries. And the only person I found who was, at the time, at least around the Manned Spacecraft Center, was George Low. And his diary actually is available now, as I understand it, for reading. Diaries are hard to read because they keep shifting on subjects, but nevertheless, they're extremely important. And I've been more recently been very, very intrigued by going back to George Low's diary and looking at how he was viewing things that I was familiar with as happening in the space program of that time.
And are you working on a book of your own these days? What's keeping you busy?
I am, Tom, I am. I've been trying to pull together a full integration of the Apollo 17 operations with what we have learned in 43 plus years about the Valley of Taurus Littrow. And indeed about the moon itself, but mainly trying to bring together the operations and the science into a coherent way. And it's a way it's starting to belatedly write a diary of the mission.
Mm-hmm.
And that's tough to do. I'm having all sorts of challenges just on how to present the information because, again, subjects keep changing. And it is, I think, going to be hard to keep the reader's interest if there ever is a reader. But nevertheless, I think it's something that needs to be done. I think I'm in a position to write that integrated view of Apollo 17, and so I'm trying to do it. I've been working on that for a number of years, but I'm really have accelerated the effort quite a bit. And as a matter of fact, this paper that I'm currently working on for Icarus Lunar Reconnaissance Orbiter volume is part of what I've been trying to do with the book. It relates mainly to what did we learn from the operations in the Valley of Taurus Littrow.
Well, it sounds like it's going to be a very exciting read. So what advice do you have for young explorers who are hoping to follow in your footsteps?
Get absolutely the best and most diverse education that you possibly can. That is key. A subset of that is to, as you get into graduate school, to learn how to concentrate on a project and carry it through to completion. That's what a PhD ought to be. It's training for that. It doesn't make much difference what the subject is. It's just that you need to learn how to manage your resources to bring a project to completion. But most importantly, from elementary school on up, you've got to learn as much as you possibly can about as many different subjects as you can handle. And I include history as part of that. That unfortunately is not taught as it should be in our school system today. But you can get history by reading, and every young person should make it a project of their own to read history, a little bit of history every day. And there are many, many good books out there that one can go to in order to learn both American history, world history, and also the history of exploration, as I said earlier. That it's important to understand what has motivated people to explore if you want to be an explorer yourself.
That's great advice. Thank you.
Terrific, Jack. That was a wonderful interview.
No, I just enjoyed chatting with you, and that's great. Thanks. Great questions.
Well, thank you so much for joining us today. We've really appreciated the time with you and our discussion with you.
STEM Talk. STEM Talk. STEM Talk. STEM Talk. STEM Talk.
So that was an absolutely fascinating, information-packed interview with Senator Jack Schmitt.
He's a very rare individual with skill sets extending across a broad range of endeavors and topics. And I love the excitement and passion that he still brings to the game.
Absolutely, and I can say as a young scientist that hearing that enthusiasm and passion in his voice is contagious, even for somebody like me.
He's a wonderful role model, and glad he took the time to do the show, and everyone at IHMC is proud to have him as a colleague.
Thank you for listening to STEM Talk. We want this podcast to be discovered by others, so please take a minute to go to iTunes to rate the podcast and perhaps even write a review. More information about this and other episodes can be found at our website, stemtalk.us. There, you can also find more information about the guests we interview.